Form 4 Mathematics Circle Properties Third Term SOW Reference Chapter 17 Page number 318 to 338. Objectives. After this presentation, students will be able to define and explain the concept of a circle and to identify different parts of a circle and to explain the relation between the angles, chords, tangents of a circle and to solve problems involving circles. There are a lot of circle theorems. Theorem number 1. Any angle in a semicircle is 90 degrees. As an example, in this diagram you can see FC is the diameter of the circle. So, which angle are equal to 90 degrees? Angle A should be a 90 degree angle because FC is the diameter of the circle, and angle B also should be a 90 degree angle. Not only A and B, you can see E and D angles also should be 90 degrees because FC is the diameter of the circle, and any angles subtended by FC should be equal to 90 degrees. So theorem number 2, angle in a same segment are equal. Now here you can see this diagram. Which angles are equal here? So angle in a same segment should be equal. So you can see these red crosses, those angles should be equal because those angles are in a same segment. Not only those angles, you can see that black crosses, those angles also should be equal because those angles also in a same segment. Theorem number 3. The angle at the center is twice of the angle at the circumference of the circle. So as an example, you can see this diagram. I have marked angle at the center as a red dot and angle at the circumference as a green dot. So it's like an arrowhead. So angle at the center, red color dot, should be twice of angle at the circumference. Here you can see this second diagram also. Angle at the center I have marked as red dot and angle at the circumference I have marked as green dot. So the value of red dot should be twice of the value of green dot. So at the same time, like this question also can come, you can see that obtuse angle represented by red dot should be twice of the green color dot, the angle represented by green color dot. At the same time, these kind of special cases also can come. You can see here diameter and the angle at the circumference I have mentioned as green dot, and angle at the center I have mentioned as red color dot. So always the value of red color dot should be twice of the value of green color dot. So in additionally, you know that angle at the center means when you join center to the circumference, radius is coming. So those two lengths always equal. So that means always it produces isosceles triangle. Then the opposite angles of isosceles triangle always equal. So then this theory you can use to find the angles. So it's very important for you all when you doing the sums. Now here also I have marked angle at the center as a red dot and angle at the circumference as a green dot. Theorem number 4. Opposite angles in a cyclic quadrilateral add up to 180. So here you can see a cyclic quadrilateral. So cyclic quadrilateral means all the vertex point of the quadrilateral should be there in the circumference. Otherwise that is not a cyclic quadrilateral. So cyclic quadrilateral means all the 4 points, all the 4 vertex points should be there in the circumference. So here in this diagram you can see all the 4 vertex points are there in the circumference. So that should be a cyclic quadrilateral. So the theorem is opposite angles of cyclic quadrilaterals are add up to 180. So you can see here the angle of A and C are opposite angles of this cyclic quadrilateral. So A plus C should be 180 degrees. And at the same time you can see angle of D and B are opposite angles of this cyclic quadrilateral. So D plus B also should be equal to 180. Theorem number 5. The angle between the tangent and the radius is 90 degrees. Tangent means a line we are going to draw outside of the circle that should touch the circumference at once. So when you join the center of the circle and what is the point it touch the circumference, always that angle produce 90 degrees. So as an example you can see this diagram, those two angles should be equal to 90 degrees. So tangent touch the circle at once, and the most important thing is the angle between the radius and the tangent always equal to the 90 degrees. So that is the theorem number 5. Theorem number 6. The angle between the tangent and chord is equal to any angle in the alternate segment. In this diagram I have mentioned what are the alternate segments angles. Those angles always equal in size. So in additionally I am going to mark what are the alternate segment angles for these 4 circles. From the white color dots I am going to represent alternate segment pairs. So always these alternate segment angles are equal in size. So the value of these white dots always equal in size. Theorem number 7. Tangent from an external point are equal in size. So when you draw two tangents from an external point, those two tangents always equal in length. So I am going to draw two tangents from this external point. So those two tangents always equal in length. In additionally, I am going to join those 2 points with the center. So you can create a kite shape here. Let's see how to use circle theorems to find an angle. As an example, find the angle of x in this diagram. So here angle x means that is angle subtended by radius. Before finding the value of x, we need to find the value of y, that is angle subtended by circumference. So how to find the value of y? So you can see all the 4 points of this quadrilateral, they are in the circumference. That means that quadrilateral is cyclic quadrilateral. We know that from the circle theorem, opposite angles of cyclic quadrilateral add up to 180. Therefore 120 plus y should be equal to 180, because y and 120 is opposite angles of a cyclic quadrilateral. So then the value of y is 60. Then you can see here angle of y means angle subtended by circumference, and angle of x means angle subtended by center. From the circle theorem, we know that angle subtended by circumference is half of angle subtended by center. So then the angle subtended by circumference is 60. Then angle subtended by radius should be twice of 60. That means angle subtended by radius should be equal to 120. So the value of x should be 120. Summary of the presentations. We learn about circle theorems. The first theorem we learn angle subtended by radius is twice of angle subtended by circumference. And we learn about the next theorem, angle at the same arc are equal, or else angle subtended by same chord are equal. Then the next theorem we learn angle at a semicircle is a 90-degree angle. Then the next theorem we learn about cyclic quadrilateral. So the opposite angles of cyclic quadrilateral add up to 180. Then the next theorem we learn about alternate segment theorems. We know that alternate segment angles are equal in size. Children, now pause this video or else turn to page number 330 and 334 and try to do the exercise 17.2 and 17.3 using this presentation. And turn to page number 338 and 341 and try to do review exercise 17 using the circle theorems. I hope you all got something from my presentation. Thank you very much.